Hello everyone. Today I'll be talking about my presentation, which is based on understanding the public opinions on banning the single use plastics. So let's dive into the topic. Single use plastics like bags, bottles have become a major concern across the world. The plastics are used once and then thrown away, leading to growing pollution. As awareness has increased, there has been a strong push towards banning the single use plastics to protect the environment and public health. Many governments have even discussed the policies to either limited or eliminate these plastics from everyday life. However, the conversation is not simple. Some groups strongly supports it, while the others don't want oppose the ban as the alternatives are too costly. And this project aims to explore those different points of view by analyzing the real world articles and discussing around the plastic ban debate. So the main goal of the article is to uncover the hidden patterns, what and the major themes in the text beyond just reading individual opinions. And another key goal was to predict stance of an article, whether it supports, opposes, stay neutral, or is totally unrelated to the topic. Finally, I aim to show how ideas about environment, government policy, and corporate actions are often connected in public conversation around the plastic bans. So let's the data for this project was taken from News API and the Guardian API. I targeted the articles and discussion that focuses on the single-use plastic and plastic bans and related environmental concerns. Each article was labeled into one of the four categories. After combining it, we had nearly 3,400 usable articles after cleaning and all. And we even use count vectorization further for our model, so that we can use the text for our models. And it as number makes it easier for the machine models to understand the text. So this is how it looked in before, when I just extracted from both the APIs. And on the right side you can see the number of articles are present for each particular label. Okay. Unsupervised methods. So to begin with, when I got my data and all, I wanted to apply some unsupervised learning to see how they are grouping well together, using the clustering to see, to even use ARM to discover strong word pairings, and even LDA to uncover the hidden topics and themes that appeared across many articles. This techniques helped me build an overall view of how different conversation around single-use plastic connect together. So let's dive into the clustering findings. And this, on the left side, you can see the PCF lot. It was done for k equals to 3 using the k means. And in this, we can see only three of the things were detected because of the silhouette score that we got, in which k equals to 3 was more prominent to use for finding out the clusterings. But on the second side, you can see we got Denatron, in which it is clearly visible that there are four topics present in the data set, being the support band being the bigger one. On the right side, you can see the box is bigger, while unrelated was hardly even present in the data set. So, by using both the PC and Denatron, we can see there are public discussions about plastic bans. It can fall into three or four categories. Okay, let's dive into the ARM findings. And this, you can see there is a last cluster on the right side. It shows words like Saudi Arabia, global countries, word, climate. These are often paired together, which is bringing us to a point, making us understand the articles are not just related to one small region or something. It's on a global scale, talking about climatic change, environmental impacts on it. And there are some other small clusters also present, like Los Angeles, Hong Kong, which indicates it was present, those articles mainly would have arise from those local organizations or the government from there. And even the words like forever chemicals and fast points out towards the chemical pollution. So it ARM was able to help us to understand the conversation was not just around the plastic, but it was towards the climate actions, government policies, and chemical safeties. Now let's dive into the LDA findings. LDA findings, on the left side you can see the intertopic distance map. In this, each circle is showing each topic it's associated with, while on the right side you can see the 30 most common words which are present. And the right it's we can see the keywords like plastic, energy, climate, waste, recycling, government, and packing. This topics come from that public discussions are not just limited to one issue, they are like overall how it affects everyone in general in everyday life, and how government is taking actions towards or suggesting practice to save the environment. So let's dive into our supervised methods. So after doing the unsupervised, I went and used naive Bayes as a baseline model, decision tree for easy interpretation, SVM which to find out like which are the complex patterns, and I used three different kernels for it. And finally, I used neural networks to capture deeper and more subtle pattern, like to understand more subtle patterns from text, aiming for a stronger prediction. So before we dive into the models, I just want to let you all know that the data set that I used was common across all the models. So the data was like using the count vectorization, the text was changed into the numbers, and the labels were kept also uh, encoded. While and there were four labels in particular. One was supporting band, opposing band, neutral, and unrelated. And finally the data was split into two halves, 75% being uh, training set and 25% being the testing set. So let's dive into the results that we got from naive base. On the left side you can see like we got the accuracy to be 67.17%, and from the classification report we can clearly see that uh, the performance metrics like for support band, like it was predicted with strong precision and recoil, while the model was struggling a lot with respect to neutral and opposing band categories. On the right side, the confusion matrix also visualizes the same prediction, and we can see that support band was very easy to identify, while the model was struggling to understand uh, if the opposed band or neutral were like it was not able to predict between those two. So overall, we can say like Naive Bayes provided a solid baseline performance by capturing key patterns in text and setting a strong foundation for our like for comparing the other models. So let's dive into decision tree. And this we didn't get that great results compared to the Naive Bayes, but like the model was also predicting was on the same like similar to the naive base. It was able to predict support band but was getting confused a lot when it came to oppose ban and neutral topics. And even the confusion matrix suggested that to further understand the decision tree, I used like three different depths of 2 3 5. uh, with the smaller depth, it was like it was very easy to interpret, but like it was missing a lot of information. And like to increase it, I went to level maximum depth of 3 and 5. In this, the trees were able to capture more complex patterns, but there was also chance of like overfitting risk, because like there would be more noise. Overall, while the accuracy stayed moderate and discussion tree offered valuable transparency about how sentiment predictions were made, which was important for explaining the results in a clear way. Now let's talk about the SVM results. We used three different models. One was linear, RBF, and one was poly. In this, there were two different cost values that we took into consideration. One was C equals to 1 and one was C equals to 10. On running all of the six models, we got to know that RBF with cost of 10 was the model which outperformed the other models, and it had the accuracy of 7.62%. And on the right side I have you can see the confusion matrix of the very same model. It was able to predict the support band very well, and even it was struggling a little bit, like there was some little like overlap between the neutral and opposed band articles, while like as it is common with any emotional complex topics. But overall it was a strong performing model, you can see. And let's dive into the neural networks result. In this, on the left side, you can see the training and validation accuracy. And the test accuracy that we got was the highest among the any other model that we used before. It was 74.13. The model was trained for 10 epochs, and you can clearly see, like, with the help of the graph training versus the validation, like there is a early sign of overfitting where the training accuracies like keep on improving while the validation accuracy is kind of like stabilized. It's not increasing too much, not decreasing also. So on the right side, it shows that the neural network was able to much better predict the support band and the neutral articles, but it failed to find the opposed ban and unrelated that properly. But overall, neural network was able to capture deeper relationships and text, but highlighting the importance of carefully like and avoiding like overfitting, especially with smaller data set. So let's dive into the overall findings. We were able to like understand the public discussion around plastic ban naturally dived into like various areas like environmental concerns, business and economic, and even government regulations. We were able like support ban articles were easy to predict, while neutral and opposed was struggling a bit as they were overlapping with each other. Unsupervised methods like clustering, ARM, and LDA helped us find out the hidden themes without any pre-labeled data, showing a strong connection between topics like climate and regulation and business. Uh, Supervised models like Nibase, SVMs, and all were able to capture important patterns from text but also highlight the challenges of dealing with emotionally charged and ethical complex topics. And neural networks was the best performing model from among the others. And the final conclusion, I would say the debate of banning single use plastic is complex and multidimensional. Public discussions are not just about environment, they also involve business impact, government policies, and global health concerns. Using different machine learning models helped uncover hidden patterns, major themes, and how public sentiments form around these issues. While no single model perfectly captures every nouns, combining unsupervised and supervised methods. Finally, the project highlights the needs for stronger policies, ethical framework, and community involvement to ensure that the future discussion about the plastics are fair, sustainable, and widely supported. Thank you so much for your time.